In this video, we're going to use algebra tiles to solve two-step equations. The equation we're going to look at today is negative 2x minus 1 is equal to 5. Now, before we can get into solving, we need to review what our algebra tiles actually represent. So you have a couple different types of tiles. The first is this green rectangle. This algebra tile represents our variable. We're going to refer to it as x, but it can really represent any variable in an equation. We just most often see it as x. When you have a red rectangle, that is representing a negative variable, so we're going to refer to that as negative x. This yellow square represents a unit or a positive 1, so I'll refer to those as units a lot of times. The red square is negative 1. Now that we've identified our algebra tiles, I want to talk about one more thing that's going to be really useful as we're solving our equations. So something that you're going to hear me refer to is a zero pair, okay? So what this is, I'll use units for an example. So if I have a single unit, a positive unit, and a negative unit, if we add those together, combine them together, what would that make? Positive 1 plus negative 1. That's going to make 0. So we refer to a positive and a negative unit together as a zero pair. You can make zero pairs with variables as well, but for our example today, we're not going to have to worry about that. We're just going to use it for units. So there's our equation. So we're going to first start by just using our algebra tiles to represent the equation. On the left side, I have negative 2x, or two negative variables. So remember, a negative variable is represented by a red rectangle. Minus 1, so that's a single negative unit. And on the right side, it's equal to 5, positive 5. So we're going to put 1, 2, 3, 4, 5 positive units, okay? Whenever we're solving an equation, our goal is to isolate the variable, so get the variable by itself. Remember, these are our variable tiles, but these are negative. We always want to end up with a single positive variable when we can. So we know that we're going to have to get these positive, but before we can do that, let's just focus on isolating the variable, okay? So let's get rid of this negative unit. Whenever solving equations, anything you do to one side of the equation, you have to do the same thing to the other side. So if I wanted to just take away this negative unit, I would have to take away a negative unit on the right. However, I don't have a negative unit on the right. So let's think about what we talked about at the beginning of the video. How could I turn this into 0 or make a zero pair with it? I could put down a positive 1 on the left, and if I do that, I have to put a positive 1 on the right. That allows me to create a zero pair and take that away from the left side of the equation. Okay, let's see what we have now. We have negative 2 variables is equal to 1, 2, 3, 4, 5, 6, okay? All right, so this next part can get a little tricky because if we're used to just working with positive variables, we would think about, well, if I have 2 variables on the left and I want to think about them in terms of 1, I'm going to split the left side into 2 equal groups. So I have one variable and another. Let's split the right side into 2 equal groups. So one group, okay? So each negative variable is equal to 3 units. Negative variable is equal to 3 units. But we want our variable to be positive. So with algebra tiles, if I want to flip this tile and make it positive, we can do that if we do that to every single tile on the mat, okay? So this is what I mean. If we want to flip that, we have to flip every single tile on the mat, okay? If we were writing this down algebraically, that would be like dividing by a negative. Okay, so again, what we just did is if we want to flip a tile, you can do that if you flip every single tile on the mat. So let's see what we have now. One variable, or 1x, is equal to negative 3. So our final answer, we would say x is equal to negative 3. Something that I always like to do after I've solved an equation, whether I'm just using algebra tiles or writing it down algebraically, is to always check my solution. So we're going to do that using algebra tiles, okay? So let's first start by just representing the solution we found. We found that x was equal to -3. So let's represent that with our tiles. X is equal to -3. Okay. Now let's represent our original equation. We had -2x, or two negative variables, minus 1, was equal to +5. So 1, 2, 3, 4, 5. Okay, so this was our original equation, and this is the solution we found. So you may have heard about substituting in your solution to check your answer. That's exactly what we're going to do with the tiles, okay? So everywhere we have a variable, we're going to substitute what it is equal to. In this case, positive x is equal to -3. Now, in our equation that we started with, we don't have positive x's, we only have negative x's. So let's think about our solution in terms of negative x. If positive x is equal to -3, then negative x, if we flip that, let's flip all these. Negative x is equal to +3. So we just applied that same principle that we used to solve our equation. If I flip one tile, I have to do the same to all the other tiles on the mat, okay? So again, just to show you what I did, because I know that this is kind of strange when we get to flipping tiles. If positive x is equal to -3, then the opposite is true. Negative x is equal to +3, okay? So I know that negative x is equal to +3. So everywhere I have a negative x, I'm going to plug in, literally substitute it with +3. So there's a negative x. I'm going to replace that with +3. For this negative x, I'm also going to replace that with +3. Okay, I'm going to take this off the mat just so it doesn't confuse us. And let's look at what we have on the left side. I've got 6 positives and 1 negative, and on the right side I've got 5 positives. Well, it doesn't look equal, but I know that anytime I have a positive and a negative unit together, that's a 0 pair. I can take that off the board. So let's see what we have. 5 positives on the left, 5 positive on the right. Our equation is balanced. That's exactly what we want, and that proves that our solution was correct.